This video is brought to you by electricalexamcoach.com, offering the #1 electrical exam prep series. You can take our paid version with the Unlimited Testing Center, but you can also take our free version that is completely free without the Unlimited Testing Center. Also, if these videos have been helping you at any time, you can also go there and pay it forward to see it head on to the next generation. I am the Electrical Code Coach. Let's go ahead and get to it. Hey y'all, what's up? It's the Electrical Code Coach, and this is week 3 of the Electrical Code Coach training program. I'm super excited that I get to be a part of your journey, and you may have noticed that we have something called the Master Series as well. But you have to master this series first before you can ever move on to the Master Series. I want you guys to go as high as you can go in the field, and I'm here to support you in every way that I can, but you have to go through the motions. You have to learn this core content in the 10-week series before you move on and go into the Master Series. Super excited I get to be a part of your journey. This week, we are actually diving into dryer calculations and range calculations as we work through a whole house load calculation. I am the Electrical Code Coach. You can email me anytime at electricalcodecoach@gmail.com. Let's get to it. All right, y'all, so before we jump into higher wattage appliances, we need to learn a few things. So let's go ahead and take a look at this. Last week, we learned that a VA is equivalent to a watt. Remember, 1 VA equals 1 watt as far as our testing goes. So what is a kVA? And in all of our testing, it's going to be the same as a kW, which is a kilowatt, which equals 1,000 watts. So 1 kVA is equivalent to 1 kW. And you're going to hear them used interchangeably in your testing and also in these lessons. So if we say that a dryer is 5 kW, that means it's a 5,000 watt dryer. Or for our calculations, you may hear it called 5 kVA, which is equivalent to 5,000 VAs. So it's very simple. First, understanding what a kilowatt is, and then understanding, what it is equal to. So 1 kilowatt is equal to 1,000 watts. 1 kVA is equal to 1,000 VA, and learning how to interchange them back and forth and not being intimidated when you see VA or watts posted, and understanding that they are interchangeable. All right, y'all, so let's learn how to convert back and forth between kVA and VA. So let's go from kVA to VA. So it's very simple. Let's say we have 5 kVA and we want to convert to VA. All we have to do is multiply. So we take our kVA and multiply it by 1,000, and that's going to give us 5,000 VA. Same thing if we're wanting to go from VAs to kVA. What we'll do is we'll take our total, which in this case is 5,000 VA, and what we're going to do is just divide it by 1,000, and that will let us know how many kVA we have. And remember, this is equivalent to a watt, so you can do this back and forth with watts and kilowatts as well. All right, y'all, let's jump right into it. What is the total VA load you would calculate for one dryer with a nameplate rating of 4,500 watts in a residential home using the standard method? Remember, you always have to figure out, am I using the standard method or am I using the optional method? I do want to note that in the absence of it mentioning a method, always default to the standard method. So let's go ahead and pick this question apart. Let's use our keyword and index process and take a look at it here. So what is our overall theme of this question? What are we talking about? We're talking about dryers, aren't we? So let's go ahead, let's head over to D in the index and let's see what we find. Pause the video now if you need to. Take a minute, get over to D in the index. Okay, so when we get over to D in the index, we do find that there are dryer, clothes, but it actually sends us to another code section. It tells us to go see clothes dryers. All right, y'all, I just want to take a minute and let you know that you're going to run into things like this in the testing center. And when you're got the pressure on you and everything's on you and you're flipping and you get back to the index and it says, go see this, you're like, oh, forget about it. And you try to maybe go look for a new keyword or something in the question. Just follow where the codebook sends you, because a lot of times it'll pay off. Let's get to it. And that's the truth. It'll take you exactly where you need to be inside the code. Sometimes it'll send you on a rabbit trail, but often it will take you to, sometimes you'll get there and then it'll tell you, you'll bounce around and move all over. But don't be afraid and don't let the pressure get you if you hit out a strike on the first time. If you get there and it says, go see this, when I first started testing, I would almost get frustrated and annoyed with it, and I wouldn't go follow where the codebook was leading me. I want you to be prepared to do that. You're going to face things like that where it sends you to another part of the index. Make sure that you follow through. So when we head over to clothes dryer, what do we find? Well, when we flip over there, it says calculations is the first one, or it's right there at the beginning, depending on your code cycle. So with that being said, now we know we're exactly where we need to be. We followed there. We went from dryer, comma, close, over to close dryer, and right there, calculations, boom, we know that we're probably going to be in the right section. We're still going to keep our hand in the back of the code book just in case we need to come back. So when we flip over there, we flip over to 220.54. And if we notice there's a theme happening here, that any time it has to do with calculations, almost every time we're ending up back in 220, which we're going to talk about here in the next slide. Now that we get there, we always look at the black bold headings and make sure that we're in the right section. So when we get to 220.54, we read the black bold heading, we make sure that's about dryers, it feels like we're in the right place, and let's go ahead and read the code now. So it says loads for household electric dryers shall be either 5,000 watts or the nameplate rating. Okay, so it's either 5,000 watts as a minimum or the nameplate rating if it's larger than 5,000 watts. And we're going to do a million of these questions, so don't feel like you have to fully understand that right now. But the code is stating that at a minimum, if you have a clothes dryer, you're required to calculate it for your load calc at 5,000 watts. But if it's larger than 5,000, then we're going to calculate it at whatever the nameplate is. So let's go ahead and look at that here. So we're going to do it at 5,000 VAs. Or the nameplate, whichever one is larger. I do want to note that every piece of equipment should have a nameplate rating stating its voltage, amperage, and or wattage. But remember last week we learned out how to figure out the wattage or the amperage or the voltage if we had any of the other two known pieces of the puzzle trying to figure this out. So when we're looking at this question here, back to answering our original question, what would we calculate for a dryer that had a nameplate rating of 4,500 watts in the residential home? Using the standard method, we would choose 5 because at a minimum, it's required to be 5,000 watts. Great job. Let's take a look at another one. What is the total VA load you would calculate for one dryer rated at 5,200 VAs in a residential home using the standard method? So it's basically asking the same thing. We're dealing with the standard method. How many VAs are we going to calculate? So I want us to try a new technique here. And I want us to try flipping straight to our calculations tab. Okay, and the reason is because we're starting to see a theme is that every time that it has to deal with the calculation, we're ending up back in Article 220. Now that's not going to be universal, but it's going to be very often. So let's try flipping straight to our calculations tab and just using the black bold heading method. Now this is like a precursor into how well you're going to be able to navigate the code book later in the series and in the game. That you'll say, hey, that's grounding and bonding. Let me use one of my grounding and bonding tabs and start reading black bold headings. Although we will primarily be using the keyword and index process, once you become more familiar with the code, you'll be able to use your tabs more often and use a mix of the index process and the black bold headings. So let's go ahead and flip straight to Article 220. And I just want you to look at the black bold headings very quickly, flipping through until you start seeing something about dryers. So go ahead and pause the video now and do that. Okay, so once we do that, it doesn't take us long to establish, where we're at in the code, and we end up right back at 220.54. So that's another way to look at it and tackle it, is to use the black bold headings if you feel like you're in the right section. So we end up in 220.54, same rules apply. We have to use 5,000 as a minimum or the nameplate rating. So in this case, we're going to use the larger, and in this case, it's the nameplate rating. So we would actually select C. Great job. All right, this is a fun little graphic just to remind us that a kVA is the same as a kW for our load calculations. That's why you'll see me use them a bunch of different ways. I'll use watts, then I'll use VAs, then I'll use kVAs, then I'll use kWs. I just want you to be familiar and understand, because you could be in the test and they listed any one of those ways. Let's get to it. What is the total VA load you would calculate for a duplex with one dryer in each unit and a nameplate rating of 4,800 watts per unit using the standard method? So up until this point, we've been in Article 220.54, but now let's learn about Table 220.54. We're on page 73 in the 2017 and page 77 in the 2020. If you're in a different code cycle, don't worry. You can find it. Just head to Article 220.54 and then look around for the tables, and you'll find Table 220.54. The information hasn't changed in the last 10 cycles, and it's not going to change anytime soon. So this is going to be universal across the board. So with that being said, we go ahead and head there. Now, the first thing that we do anytime we get to a table or an article is we read the black bold heading to make sure we're in the right table. This one says demand factors for household electric clothes dryers. I feel like we're in the right table. Our question's asking about dryers. We're in a household setting. Let's go ahead and get to it. So now we're going to use the other black bold headings of this table to navigate the table. And that's how we navigate every table. So on the left-hand side is the number of dryers. That's pretty simple. Now let's look at the other black bold heading. Go over to the next column to the right, and it says demand factor, and it's in percentages. Remember, we learned previously that demand factors are either increasing the demand or decreasing the demand that you have to calculate for your load calculation. So let's say you had 6 dryers. When you go over there and tee off, it says 75%. So whatever your load was, you would just multiply by 0.75, and that would ultimately give you the demand that you would use for your calculation. Okay, so we're in between 1 and 4 ranges. Let's look at our question again. It says we have 1 dryer in each unit, and there's 2 units in the duplex. Okay, so we're going to end up with 2 dryers. So if we look at our table, starting on the left-hand side, first we select our number of dryers. We end up right there in the first one. And then we go over and tee off, and they're calculated at 100%. So there is no change here. We're not going to do any demand factor. We're not going more or less. So first we have to total them, but we have to remember, if you look at our question, these are only 4,800 watts, but I need you to commit to memory that when you're dealing with the standard method, dryers must be calculated at a minimum of 5,000. So we take that 5,000, we multiply it by our 2 units, and that's going to give us 10,000 VAs. And we're going to select A. Great job. What is the total VA load you would calculate for an 11 apartment multifamily dwelling unit with 1 dryer per unit and a nameplate rating of 4,500 watts? So we have 11 units. Each one has 1 dryer in it. Let's go. I'm going to take you through this process, and I'm going to say it over and over. So if your book was closed or if you got this question and you were somewhere else in the book, you're going to flip straight to your calculations tab, which is going to take you to Article 220. You're going to find table 220.54 because we're dealing with dryers in the standard method. We know that it tells it's a 5,000 minimum, okay, or whatever the nameplate rating is, so we're good here. All right, so the first thing that we're going to do is we're going to find our total VAs. We have 11 dryers at 5,000 each, so we're going to bear that math out first before we even worry about demand factors. So we take and bear that math out, find out what our total VAs are. Now we're going to head over and we're going to check for demand factors and find out if there are any. We're going to head to table 220.54 because it's dryers. We're going to find first, you start on the left-hand side and you find your number of dryers. So first we start on the left-hand side, find our number of dryers. Now we're going to come over and we're going to tee off with our percentage. So in this case, it's 47% for 11 dryers. So what we do is we take our total VAs, we're going to multiply it by the demand factor, 0.47. That's going to give us a new total load calculation of 25,850 VAs. And we're going to select D. Great job. What is the total VA load you would calculate for a 17 apartment multifamily dwelling unit that has 1 dryer per unit with a nameplate rating of 5,000 watts? So this one's a little bit more complicated, but we'll just go through the same motions. We're going to use Article 220.54, and it states that we have a 5,000 VA minimum or the nameplate rating. You may see me repeating things over and over. It's because I want to kind of beat it into your brain, okay? 5,000 minimum or the nameplate rating. First, we find out our total VAs. We take 17 multiplied by 5,000, and that's going to give us 85,000 VAs. That's the total that we're starting with. Then what we're going to do is we're going to check for demand factors. We're going to head to table 220.54. We're going to start on the left-hand side of the table and find our number of dryers. Then we're going to come over and we're going to find our demand factor. So this one's a little bit more complicated. It tells us that it's 47% minus 1% for each dryer past 11. All right, so let's go ahead and do this. First thing that we have to do is find out how many dryers we are past 11. So we take our total dryers and minus 11, and that's going to give us the difference. And in this case, it's 6. So we're 6 more dryers past 11. So what we do now is we are going to take our demand factor, our starting demand factor of 47%. We're going to minus that 6, and that's going to give us 41%. Does that make sense? So we started with our base percentage. We found out how many we were past 11. It was 6 more past 11. So we take our base percentage, we minus the 6%, and our new demand factor is 41%. So what we do now is we take our total. We take our total VAs, multiply it by 0.41, and that's going to give us 34,850 VAs. And we're going to select A. Great job. Now don't get discouraged by these questions. Just go over them over and over until you understand it. You can do it. All right, now we're going to jump into range and appliance load calculations. Don't get overwhelmed or frustrated by this section. It's actually a lot of fun once you learn out how to do it. I've hopefully laid it out very simply for such a complex subject. Remember, you can always email me at electricalcodecoach@gmail.com. But if you work through it and you practice, I know that you can do it. Let's get to it. All right, so for this section, our range and cooking appliance calculation questions are going to use kVA and kW interchangeably, just like we did in dryers. A kVA and a kW are considered the same for our electrical load calculations in this section. And remember, your actual test could list ranges and dryers in watts or kilowatts, which is equivalent to VAs and kVAs. I cross back and forth in our program just so you get very fluid with understanding that they go back and forth. Okay, it's just like it's the tide going out. You could be kVA, you could be kW, you can VA, you could be watt, back and forth. I want you guys to understand that it's all the same, and I want you to be confident and comfortable on how to convert back and forth. How many VAs would you calculate for a 9 kW range in a single family dwelling unit in Piney Flats using the standard method? So remember, anytime that we don't know something or we're on a new topic, we're always going to use the keyword and index process. So what do you feel like the overall theme is? What are they talking about? What's the topic? It's ranges, isn't it? They're talking about ranges. So let's go ahead and head there. So let's head to R in the index and let's see what we find. Go ahead and pause the video now if you need to, and we'll catch up together in R. Now remember, when we get there, we're looking to see if there is ranges at all. That doesn't mean it's going to be in the index, but let's see. It's in alphabetical order, so we go to R, RA, and we do find ranges. There is a ranges section. So now we need to look under that heading and see if we find any more keywords in our question. So we look down. First one is branch circuits. Yeah, it is a branch circuit, but our question doesn't say anything about it. So let's go down farther. The next one says calculation of load. Bingo. We've hit ranges and we've hit calculate. We are hit 2 of the major keywords, major themes inside of our question. And there's a couple different things listed here. Let's go ahead and look at them. It says Article 220.55, and then it says Table 220.55. They're matching, so we can keep a piece of paper in the back of the index just in case we need to get back there. But there's no conflicting code articles, so we're probably in the right section. So let's go ahead and head over to Article 220.55. Take a minute, pause the video if you need to, and we'll catch up when we get there. Okay, so when we get there, first thing that we're going to do is we're going to always read the black bold heading. That lets us know that whether or not we're in the right code section, because sometimes you can just misread it and think it's 230.55, and you get over to 230.55 and you start reading the paragraph and you're like, wait a second, this doesn't have anything to do with it. That's why as soon as you get to that section, make sure you read the black bold heading to make sure you're in the right article. So 220.55, it says electric cooking appliances in dwelling units. Bingo, I feel like we're in the right section. Now you can go ahead and read that whole paragraph there. I'm going to give you the highlights. It lets us know that when we're dealing with ranges, wall-mounted ovens, counter-mounted cooking units, or similar things that are in excess of 1 3/4 kW, we're allowed to use Table 220.55. So we're going to head over to Table 220.55 and we're going to break it down. It's a very extensive table. In the next slide, we're going to go over it piece by piece. Don't get overwhelmed, get excited, okay, because you're learning something new. Remember, it's not what are you getting here, but what are you becoming here? Ask that at your job, at your church, at the place where you play ball. Not what am I getting here, but what am I becoming here? Same thing with this video series. Ask not what are you getting here, but what are you becoming? Who are you becoming? I'm super excited for you. Let's give you a little tip about finding tables while we're right here. If you read in the paragraph under a black bold heading and it says that you're allowed to use a table, or it directs you to use a table, what you're going to do is you're going to look at the surrounding tables. It's going to be within a couple pages. So let's look to the left here. It says Table 220.42. That's not right. We're looking for 220.55. Now let's look toward the right-hand side. It says table 220.54. Well, we need a little bit more than that, so we know that we got to flip the page. Depending on your code cycle, it may be on the same page. But in the 2017, it's going to be on page 74, and you have to go to the right one page, and it's going to be table 220.55. Now let's go ahead and take a minute and break this table down. All right, y'all, so let's go ahead and take a look at table 220.55. We're going to be on page 74 of the 2017 NEC and on page 78 of the 2020. So the first thing we do anytime we get to a table is we read the black bold heading. It says demand factors for loads for household electric ranges. Great, I feel like we're in the right table. Now, how we read any and all of our tables is we read them from top to bottom and left to right using the black bold headings to navigate the table. So let's go ahead and do that now. So across the top, it says demand factors in percentage. And then it says see notes, and we're going to cover all this. So then starting on the left-hand side, it says number of appliances. So that's going to be the number of ranges or cooking units that you have. Then we go over one column, it's column A. And then we go over one column, it's column B. And then all the way over to the right, there's column C. And let's break these down one at a time. So there's really two ways to classify this table. You're either going to be applying a demand factor or there's going to be a replacement kW value. Let's break it down one step at a time. So let's go ahead and look at column A. Now, column A and B are going to be a demand factor, okay? You're going to actually do a multiplier like we've been doing in the past. So we're actually going to be applying a demand factor. So if your range or set of ranges falls in between 1 3/4 kW and 3.5 kW, then you're going to use column A. So let's imagine that we had one range and it was 3 kW. What we would do is we would come over to column A. We would take our 3,000, which is 3 kW. We would take our 3,000 VAs and we would multiply it by 0.80. That would be our new demand for our service or feeder, okay? So that's how we'd apply column A. Now let's look at column B. It is also a demand factor, and it's for ranges that fall in between 3.5 and 8 3/4. So if we had one range that was 7 kW, we would come over to the left-hand side first and find our number of appliances. Then we would come over and tee off with the respective demand factor in column B. And in this case, it's 0.80. So we'd take our 7,000 VAs, multiply it by 0.80, and that would be our new demand. Same thing if we had two appliances. So let's imagine that we had two 7 kW. We would go on the left-hand side and first find our number of appliances. Then we would come over to column B because our range is in between 3.5 and 8 3/4. And we would have a 65% demand factor. We take 7, multiply it by 2. That's going to give us 14 kW or 14,000 VAs. Then we would take that and multiply it by 0.65. And that's going to give us our new demand that we actually calculate for our load calculation. Now let's look at column C. Now column C is going to be a replacement of the total demand. This is for ranges that fall in between 8 3/4 and 12 kW. So if your range falls in between 8 3/4 and 12 kW, you're actually just going to replace it with whatever value is in column C. So let's say we had a 10 kW range and we only have one of them. First thing we do is start on the left-hand side of the table and find our number of appliances. Then we're going to come over and we're going to tee off with wherever our range falls on the table. In this case, it falls in column C. It's over 8 3/4, but it's not over 12 because we said that our range was 10 kW. So for our demand factor and for our load calculation, that 10 kW is now going to be replaced with the 8. Okay? It's a apples for apples replacement. So if your range is over 8 3/4 but not over 12, you come to whatever number of ranges that you have and you come over and you tee off and you find out whatever the replacement value is. So our 10 kW range would now only be an 8 kW range as far as our load calculation goes. If we had two 10 kW ranges, two 10 kW ranges, we would go over to the left-hand side and find two appliances, and then we come over and we find out that the new replacement value for both of the ranges is 11 kW. And so on and so forth. And don't worry about having to master all this right away. We're going to work through pretty much every example. Now let's look at the notes. So we have to be mindful of our notes when we're dealing with, because column C only goes up to 12 kWs, doesn't it? So let's go down to note 1. Note 1, It's right underneath your table. It says over kW, over 12 kW through 27 kW of all of the same rating. For ranges of individuals, ranges that are rated 12, over more than 12, but not more than 27 kW, the maximum demand of column C shall be increased by 5% for each additional kW rating or major fraction thereof by the original individual value exceeds 12. And that sounds really complicated, but I break it down in the future slides and you'll know exactly how to do it, no problem. Now let's go ahead and look at note 2. This deals with ranges that are 8 3/4 or more than 8 3/4 through 27 of unequal ratings. And what it tells us to do is to average out a value by taking and adding all of the ranges together and combining them to make a total connected load. We have to use 12 kW as the minimum, okay, for each range, and then dividing that total by the number of ranges, and then the maximum demand of column C shall be increased by 5%. So I'm going to teach you how to do that. So that's if we had an 8 kW range, a 12 kW, or excuse me, we had a 12 kW range, a 13 kW range, and a 15 kW range. You know, what do we do with all those and how do we get a demand? Well, I'm going to teach you exactly how to do that shortly. And then note 3, all it says is that it reiterates that we're allowed to use column A and column B for calculating ranges that fall in that section. So, with that being said, when you read that note there, it says in lieu of using column C, you can use columns A and B. I'm going to teach you today only what it takes to pass the test, not to apply it out in the field necessarily, okay? So when you're doing testing and you have ranges that fall in either column A or column B, make sure that you're using column A or column B. Don't try to use any of the other notes, okay? Because that is what the test wants you to do. It wants the lowest demand possible, and the lowest demand possible is actually going to be if you use column A or column B. Now, don't be overwhelmed by all this information. I'm going to break it down one question at a time, and you'll be a pro by the time we get done. Let's get to it. All right, let's go ahead and answer our original question. How many VAs would you calculate for that 9 kW range? The first thing that we're always going to ask ourselves with a range question is what column or columns are we using? In this case, we're going to be using column C because our range is rated more than 8 3/4, but not over 12. So we're going to be using column C. First thing we do is we start out on the left-hand side and we find our number of ranges. Then we come over and we tee off with our respective column. In this case, it's column C, and we're going to select the replacement value, not a demand factor, it's a replacement value for one range. And in this case, it's going to be 8 kVA, and we would select C. What is the total VA load you would calculate for 3 kVA ranges in a home in Tampa, Florida? So we're going to flip straight to our calculations tab, straight to Article 220. I just want us to get in that habit of any time it's to do with the load calculation, let's just head straight to Article 220, and then we're going to become pros at flipping straight to Table 220.55 when we're dealing with ranges. All right, so the first thing we're going to establish is what column are we using? So always reread your question. What is the total load? You would calculate. We have 3 kVA ranges. So what column are we using? We head to Table 220.55, and I think we're going to be using column A because our ranges individually are rated less than 3.5 kW. So we're going to be using column A. So now we have to go down and we're going to find our number of ranges on the left-hand side, and we're going to come over and tee off and we're going to find our demand factor. So we have 3 ranges. We're going to find out that our demand factor is 70%. Now what we can do is we can actually start from scratch. And this is where you have to be careful because you have to first get the total demand and then apply the demand factor. So we have 3 ranges at 3,000 VAs each. So we take 3 multiplied by 3,000, that's going to give us 9,000 VAs. Now we apply our demand factor. We take that 9,000, we multiply it by 0.70, and that's going to give us a new total demand of 6,300 VAs. And we're going to select B. Great job. What is the total VA load you would calculate for 2 3.2 kVA cooking appliances in a home in Tampa, Florida? So we're going to flip straight to our calculations tab, straight to Article 220. We're pros, so we're going to head straight to Table 220.55 because this is a range question. Now we're going to figure out what column we're using. Reread your question. What is the total VA you would calculate for 2 3.2 kVA cooking appliances? So we know now that we're going to be in column A because we're less than 3.5. Now we're going to find our number of ranges on the left-hand side. We're going to come down and we're going to tee off. So we have two ranges. We're going to come over to column A. We're going to tee off, and we're going to find that our demand factor is 75%. And now we can start from scratch. We take our two ranges that are 3,200 VAs each. We're going to take 2 multiplied by 3,200. That's going to give us 6,400. Now we take that 6,400, we multiply it by 0.75, and that's going to give us 4,800 VAs. And we're going to select A. What is the total VA load you would calculate for one 7 kVA range in a home in Sugar Hollow? We're going to flip straight to our Calculations tab, Article 220 in our codebook. We're going to head straight to Table 220.55. All right, so the first thing we're going to do is we're going to figure out what column we're using. So we reread our question. What's the total VA? One range, 7 kVA. So we look at our table. Where does 7 fall? It falls in column B, doesn't it? So we head to column B. Now we're going to come over to the left-hand side for our number of ranges. We're going to come over. We have one range. We come over and tee off with column B to find our demand factor. Ours is 80%. So now we come back and we take our 7,000 VAs from our one range. We're going to take and multiply that by 0.80. That's going to give us a new total of 5,600 VAs, and we're going to select C. Let's get to it. All right, let's get into a little more complicated type questions. How many VAs would you calculate for a 14.6 kVA range in a single family dwelling in Asheville, North Carolina? So we're going to flip straight to our Calculations tab, Article 220. We're going to find out what column we are using. So we're in Table 220.55. We're going to find out what column we're using. Well, in this case, we're going to be using one of our notes. So anytime your range goes outside of 12 kVA, you know that you're going to be using one of your notes. You're going to be either using note 1 or note 2. Well, in this case, we're going to be dealing with note 1 because we only have one range, okay? So note 1 says for ranges that are over 12 through 27 of the same rating. So we could have more than one range, but they're all of the same kVA rating, okay? In this case, we only have one range, so it's of the same kVA rating. So what we're going to do is we're going to increase the column C value by 5% for each kilowatt rating past 12 or major fraction thereof. And I'm going to explain what that means. Let's get to it. All right, so the first thing we do is figure out how many kVA we are past 12 because it states that we have to increase the column C value 5% for each kVA past 12 or major fraction thereof. And what that means is that you're just going to round up. So ours was a 14.6 kVA range. So it's greater than, it's 5.0 or greater essentially. So we're actually going to round up to 15, okay? And that would be 3 past 12. So we take 15 minus 12, and that gives us 3 kVA past 12, okay? We had 14.6. We rounded up to 15. That is, we take our 15 that we have, we minus the original 12. That's going to give us 3. That lets us know the increase. How many more are we past 12? Now, it says that for each kVA past 12, we're going to increase the column C value by 5% for each kVA past 12. So we need to figure out our total percentage. It's a multiplier. It's another demand factor. So we take our 3 kVA past 12, multiply it by 0.05. That's going to give us 15%. Now what we do, we go back and we do our normal steps. We start on the left-hand side for our number of appliances. We come over and we tee off with column C, okay? And we're going to find that 8 kVA is our base. Now we need to increase that by 5% for each kVA above 12. We've already done the math that we are 3, which brings it to 15%. So we just take our base, which was 8 kVA, we multiply it by 1.15, and that's going to give us 9.2. Now I want to note that we are using 1 in front of the demand factor to increase it, okay? So we also could do 8 multiplied by 0.15 and then add it back to the original 8. But it's faster if you just do 8 multiplied by 1.15. That gives you your 8 back, and then it increases that 8 by 15%, and that's going to give us 9.2 kVA. So, super excited. You might have to go back through this one a couple times, but let's do another. How many VAs would you calculate for a 15.6 kVA range in a single-family dwelling in Asheville, North Carolina? So the first thing we're going to do is we're going to flip to our Calculations tab, Article 220, and we're going to decide what column we're working in, or are we using one of the notes. So we check columns A, B, and C. We know that ours is greater than 12, so we're going to be using either note 1 or note 2. In this case, we're going to be using note 1 because we just have one range and it's of equal value. So it states that we have to increase the column C value by 5% for each KW rating past 12 or fraction thereof. First thing we're going to see is how many we are past 12. We have 15.6, so we're going to round up to 16. We take 16 minus 12, and that's going to give us 4. We are 4 past 12. So now we're going to take our 4, multiply it by 0.05, and that's going to give us 20%. Now we go back to our original table and we go through the motions. We start on the left-hand side and find our number of ranges. Then we come over to our respective column, which in this case is column C, and we figure out what our base value is. Our base value is 8 kVA. So we take 8 multiplied by 1.20, that's going to give us 9.6 kVA, and we're going to select D. Great job. How many VAs would you calculate for one wall-mounted oven rated 11 kVA in a home in Mount Morris, Michigan? All right, so we're just dealing with one appliance. Now, if the question ever says branch circuit, then we're going to be using note 4. But since it doesn't mention anything about branch circuit, we're just going to go through the normal motions. So we flip straight to our calculations tab, Article 220, Table 220.55. All right, now let's figure out what column we're using. So we reread our question. We have one appliance. It is 11 kVA. So we're going to be using column C. So we start on our left-hand side for our number of appliances. We come over to column C for one range, and we're going to find out that the answer is 8 kVA. Let's get to it. How many total VAs would you calculate for an 11 kVA range, a 13 kVA range, and a 14 kVA range? All right, so we're going to use our calculations tab, head to Article 220, Table 220.55. Well, this is an unusual situation, so we know that we're going to be using one of the notes. And in this case, we're going to be using note 2. So this says for ranges that are over 12, but not over 27, we're going to use note 2. And we're going to total all of those ranges kVAs, then we're going to divide by the number of ranges we have, and we're going to treat that as a normal setup for increasing the column C value. Okay, so it sounds kind of tricky, but we're going to talk about it now. The only thing you have to watch out for with this type of question is any individual range, the minimum that it can be is 12 for this calculation. So you see our 11 kVA range, it has to be bumped up to 12 in order to do our math. Now it sounds kind of complicated, but I'm going to explain it now. All right, so the first thing from note 2, we have to use a minimum of 12 kVA. So we take our 3 ranges, we divide them by 3, and then we treat them as an average, go and apply the column C normal method for ranges that are over 12. So, but we must calculate our little range, our 11 kVA range, at 12. So we take our ranges, we take 12, we take 13 and 14, and we add them together. Those are all the kVA values. That's going to give us 39 kVAs. Now we're going to take that 39 and divide it by the number of ranges. That's going to give us 13. Now what we do is we go back and we increase the column C value for that number of ranges by 5% for each one above 12. In this case, 13 is just one above 12, so our multiplier is 5%. So we go back and we use our table like normal. So we start on the left-hand side. How many appliances we have? We have 3. So we come over and we find the value for 3 appliances. And in this case, it's 14. So we find it, and we know that we have to increase that value by 5%. So we take 14 multiplied by 1.05, and that's going to give us our increase of 0.7%. So we're going to select 14.7 kVA. Let's get to it. What is the total VA load you would calculate for a 3 kVA cooktop and 2 4 kVA wall-mounted ovens located in a house up Simmerly Creek Road? Well, the first thing that we're going to do is we're going to use our calculations tab to head to Article 220 to Table 220.55. All right, so the first thing we're going to do is we're going to figure out what column we're using. So we reread our question. We have a 3 kVA cooktop and 2 4 kVAs. So it looks like we're going to be using columns A and column B. Now this is very simple. What you do is apply the individual demand factors and then just add the total together. So let's start with our column A math. So our first range falls in column A. So we start on the left-hand side for our number of appliances, and then we slide over to column A, we find our demand factor. In this case, we find that it's 80%. So we take our column A range, which is 3,000, multiplied by 0.80, and that's going to give us 2,400. Now we're done for that part right now. Now let's do our other appliances. They fall into column B. So we start on the left-hand side for our number of appliances. We come over and fall under column B. We have 2 appliances, and we're going to find that we have a 0.65 demand factor. Now all we do is do the math. So we take our 2 ranges that fell in column B, multiply that by 4,000 because each one is rated at 4,000, and then we multiply that by 0.65. Now, just like every other part in the program, I highly encourage you, if you want to do it all in one succession like this, make sure you push the equals button in between each time. So 2 multiplied by 4,000 equals. Multiplied by 0.65 equals. That way your calculator doesn't get confused on the math. After we do that, we end up with 5,200, and we take our original 2,400 from column A, we take our 5,200 from column B, and that's going to give us a total of 7,600. Great job. And we select A. All right, you guys survived ranges, and we are going to cover it more, but that got us, in there. Just practice it over and over. I just want to do a quick recap question, and we're done. So how many total VAs would you calculate for the 2 required small appliance branch circuits and the 1 required laundry circuit in a dwelling unit? Remember we learned about that? Remember we calculate each one at 1,500 VAs, and we're going to take our 1,500 VAs multiplied by 3. That's going to give us 4,500 VAs. We have no demand factors to apply at this portion until the end of that calculation. And we are going to select C. Great job. All right, guys, you guys survived another week. Take a big, deep breath. Next week, we'll jump into week 4, continue on into load calculations. I'm so thankful I get to be a part of your journey. If there's anything that I can do for you in life or in business, just email me at electricalcodecoach@gmail.com. Let's get to it.